We're now looking at 11.12 on page 109, so we're getting 2 more properties to look at. So we're looking at the first one, so the tangent at the end of a focal chord. Okay, so remember the focal chord always goes through the focus of coordinate 0a for our parabola x squared equals 4ay. So the tangent at the end of a focal chord will always intersect at right angles on the directrix. Okay, so now we need to prove that. So basically wherever I move that focal chord around, so I've got the 2 point of contact on the parabola, draw 2 tangent, and this point here, the intersection of the 2 tangent, will move along the directrix. Okay, so I'll create a file to show you that, okay, how that looks like. But today we'll just focus on getting through the proofs. Okay, so we need to do the proofs, so we need to consider the point of intersection of the 2 tangent and the gradient of the 2 tangent. Okay, now I'm not going to go through the complete proof because we've already done parts of it already in the previous section. Okay, so we're just getting it done. So the gradient of the tangent at capital P. Does anyone remember what this is? Little p, okay. One thing you can remember, and that'll also save you a bit of time. Okay. At Q is little q, right? And the equation, the intersection point from number 4. So this is from 3, property number 3, and from property 4. Okay, so the intersection of tangent at A outside of P plus Q, comma APQ. Okay, so we've derived those already. We're just now going to use the results. Okay, so if we don't remember these results, you will need to derive that, okay, by finding the equation of the 2 tangent, solve them simultaneously, and get that intersection point. Alright, since PQ is a focal chord, okay, what's a property from that?
-1.
Yep, what? -1. PQ is -1. Okay, so that's the one of the major things you need to remember. Okay, whenever you're working with focal chords, you need to know PQ is -1. Okay, we can derive that, of course, all right, by finding the equation of the chord, all right, and then substituting the point of the focus, and you'll get this equation here. Okay, but save you a lot of time if you can remember that. Okay, so for tangent to meet at right angle, M1 times M2 must equal -1. Okay, what's the gradient of our 2 tangent? P and Q. So P times Q from that property is -1, isn't it? So P, Q equals -1. Okay, so we've shown that the 2 tangents at the end of a focal chord always meets at right angles. Okay? Always. Now we need to show that it meets on the directrix. Okay, any idea of how I'm going to do that?
Intersection of 0.
Which is? Yes, and how am I going to use that to finish off the question to show that this intersection point is always on the directrix? Substitute what?
That thing there on what is not said.
This is the y value, okay? So we need the y value of the coordinate, okay, to show that it's always that consistent value. Alright, so we've got APQ. Alright, if I substitute in PQ, it'll be negative 1 times A. So it'll be y equals negative A.
Whoa, that's really simple.
Yes, okay. Alright, so y value of intersection of tangent is APQ, and no PQ equals -1. We can only use this if we have a focal chord, okay? You can't just substitute in whatever you want. Right? You have to have a focal chord. If you don't have a focal chord, you do not have this property, okay? So, y is APQ, which equals -8, which is the equation of directrix to the parabola x squared equals y1. So therefore, tangent at end of focal chord intersect at right angle to, sorry, on. Directrix. Okay, so it doesn't matter where I move that focal chord, okay, it will just mean that coordinate will just move along that horizontal line, y equals -A, okay, whatever the values for A, P and Q are, okay, and it will always stay as the right angle along, okay, so we'll be doing this as I go through how the tangent appears. Okay, so I'll just get more vertical as you go over here and more horizontal as you're going through that turning point, okay? So as it turns, it'll always meet at right angle along that directrix. Alright, so I'll set up a little file on my, using my GeoGebra skills, and I'll show you that in a future lesson, okay? Any questions on that? Alright, that's property, that's the tangents in the focal chord. Now, next one. The tangent at a point P on a parabola is equally inclined to the axis of the parabola, this is top of page 110, and the focal chord through the point P. Okay? So what that means is in your diagram here, theta there between the focal chord and the tangent is the same angle as that tangent where it meets the y-axis. Okay? Those two angles are always equal as well. Okay. So, proof. Right, so let's do another diagram on your page ready. Let's just start setting that up. Okay, this is a sketch. You don't technically need a ruler. However, it just looks better when you use a ruler. Right. RTP required to prove. So we need to show that this angle here is equal to that angle there. Right, so what do we know? What makes a parabola? Thinking about your locus. What makes a parabola? A parabola is the locus of a path that is equidistant from. So we know from that what two things are equal. Come on. P is equal to PR by definition, isn't it? Okay, the path of the parabola, the point P, is equidistant from a fixed point and the path to the perpendicular down to a fixed line. Okay, that means this line and this whole line here is equal by definition. Can anyone see the direction the proof's going? Well, what am I proving?
That seems an isosceles triangle.
Good, okay. For that to be an isosceles triangle, okay, what do I need to show? What's one of two things I can show?
Or
Yep, one, or
PR.
Or I'll show these two angles are equal. Okay, when I show two angles are equal, I have an isosceles triangle. Okay, so that's where I'm getting at. Alright, so PR is equal to PF plus SR. So that vertical line there, the whole line there, is equal to that plus that. How long is PF? How long is the interval PS? Good. Yep.
Yeah, okay.
PS, so S is on the x-axis, so the y value is 0, and the y value for the point up here is AP squared.
Yeah.
So that take away 0 is AP squared. Okay, so in other words, the length of that interval PS. Right, how long is SR? So, we need to now have the coordinate of Q. Okay? The next thing we need to now work out is the coordinates of Q. How am I going to do that?
0 minus A.
2A. Negative 2A.
0 minus A would be that point there. So how am I going to work it out? What is the line PQ? PQ is a
Tangent.
tangent. Okay? So the equation of PQ, okay, equation of the tangent, so we have gradient P, okay, and the equation given to you in your notes there, okay, so I won't derive it. Y take away Px plus AP squared equals 0 from property number 3. Okay, so I'll derive that then. Right, so what do I know about my coordinates at Q? X is 0. So at Q, X equals 0. So Y take away P lots of 0 plus AP squared is 0. So Y is equal to A P squared, negative AP squared.
Right, yeah.
Okay, so can I use that information now to do what?
That's the one. Now.
Okay, what am I showing? I'm showing these two angles here are equal. Okay, to show these two angles are equal, what do I need to show first? These two are equal. Alright, so we've got a notation for that one. How long is FQ?
AP squared.
Pardon?
AP squared.
Not finished?
Oh, F to Q. AP squared plus A.
Good. Okay, so PQ, the interval OQ is AP squared long. Okay, the interval OF is A units long. Okay, so FQ is going to equal FO plus OQ, so A plus AP squared. Okay, underneath that equals FP, because we've stated at the start FP is equal to PR, so if PR equals these two, that must be the value that's equal to FP. FP and FQ are equal. Alright, so therefore FP is equal to FQ, because they're both AP squared plus A units long. Okay, so I had to show PR first, but I've already known from my equation of the locket that these conditions must be met. Okay, so therefore this much equals that, which equals AP squared plus A. And then with the other side, I've shown that it's also the same distance. Okay, so therefore the two sides here and here must also be equal. Okay. Implies that triangle FPQ is isosceles, which implies that angle FPQ equals angle PQO from my diagram. I'll write that line again. Okay? So in short, you draw a tangent at the point P, you draw that to the focal chord. The angle formed between the focal chord and the tangent is equal to the angle drawn from that tangent down to the y-axis. Okay? So this angle here equals that angle there. Okay? As long as you've had that focal chord. I know. Pretty cool, I thought.
Imagine doing this when it's not an origin. When it's basically diagonally.
Okay, so that's the proofs. All of them now. How do you feel about the topic now?
I can't remember that.
I'm still as cool since we are.
Okay. Now, I've never seen in exams you to drive anything like this. Okay, I haven't personally seen it, though I haven't looked through all the past HSC exams under a microscope or anything like that. Okay. However, these are the styles of questions you can expect in assessment. So, the key for this topic, okay, well, I've told you a couple of things. You know that if you have a focal chord, you need to know that PQ is equal to -1. Okay, you also, one handy thing to know is the tangent at the point P or at the point Q has gradient P's and Q. Okay, and you can derive that quickly. Alright, but the most important thing at the moment is PQ equals -1 if you have the focal chord. Okay, don't remember your formula, derive them. Okay, the only reason I've used them because I've already derived them. I'm not taking up time deriving them again because I've already done it. Okay, but in terms of your assessments, okay, you'll probably need to go through that. Okay, so the key for this topic, to find the equation of a locus, the parameters need to be eliminated. Okay, that's your key for this topic. So to find the equation of the locus for the styles questions you're about to find, okay, we're about to go through, you need to eliminate any parameters that are included in the diagram. Okay, this will be achieved by creating equation and substituting equations into formulas. Okay, so we had the PQ equals -1 and we substituted that elsewhere and we got rid of that parameter. Okay, that's the style of the progress of the topic that you'll be doing. Right, let's look at a couple of examples. Right, the tangent P and Q on the parabola x squared equals 4ay meet at T, and M is the midpoint of PQ. I suggest you draw a diagram. Okay, always draw a diagram, especially when you don't have one. Right. You're not getting marked in diagram. Okay, so be as messy as you want as long as you can read it. Nice big diagrams. That's way too small. When you draw diagrams, you're looking at least a third of your page. Okay? When you draw your diagrams, you're looking at least a third of your page. So, okay, because you need to add information to this and you don't want things squashed together. Okay, so nice and big. So that we can write it all. Right, so we've got point P, 2AP, AP squared, and point Q, 2AQ, AQ squared. On the parabola x squared equals 4ay, meet at T. So let's draw two tangent. They meet at point T. And M is the midpoint of PQ. Right. You do not know that this is a focal chord, okay, so therefore you cannot assume that's a focal chord, and in your diagrams make it look like that you don't have a focal chord. Okay? Right, so always start with the diagram. Alright, if you do nothing else on this question, start with your diagram. Alright. Show that the equation of the tangent at P is that. Okay, so we're going to start from the start in terms of deriving everything. Okay, assuming we haven't remembered the formulas, we're going to start deriving everything from the start. So we need to show the equation of the tangent at P is that. So how do I show the equation of a tangent? We find the gradient by using our calculus skills. So y is x squared on 4a. Okay, so we're verifying in the question as well, it has told us x squared equals 4ay. So that's why I've drawn the parabola like that. Differentiate. Okay, so at x is 2ap, y dash is going to be 2ap over 2a, check with p. Alright, so we're expecting that result. But if you sit in your assessment and you've forgotten, that's what you need to do. Y take away y1 is m, x take away x1. Okay, so we've got a point, we've got the gradient, we can now substitute in the formula. Okay, looking at your answer, we have y equals something, okay? So y is equal to px minus 2ap squared, and then I'm going to move this over to the other side. Plus ap squared. Okay, so if you cannot get this result, you can continue the question because this is a show question. Okay, if you cannot get that result, you continue with the answer because they've told it to you. Remembering when the question's set up, so we've got I through to V, alright, you're often building up to that last point. You're going to use previous knowledge. Okay, so what we've just worked out, you're going to use that to part of your next question. Right, part 2, find the coordinates of T. So what is T again? Okay, so to find the intersection of two tangents, what do we need to do?
Solve the two.
Yes, okay, so we've got an equation of one tangent, we need the equation of the other one. Alright, so y is px minus ap squared. Okay, so similarly, tangent at Q. Can you tell me what the tangent at Q equation is going to be?
Qx minus aq squared.
So?
Qx minus aq squared.
Yep. So y is Qx minus a. So don't spend your time deriving that one. Alright, use your results. Okay. So equation 1, equation 2. So 1 into 2. We're going to eliminate the y variable using the substitution method. So px take away, sorry, yep, px take away a p squared is equal to qx take away a q squared. Solve for x. What do I do first?
Get x on one side.
Yep. So px take away qx is going to be a p squared take away a q squared, moving the constant on the other side. Right, so we factorise the a out. We have left a p squared take away 2q squared. And we have learned in mathematics how to factorise that difference of 2 squares. And I'm doing that because I've got a p takeaway here and I can cancel it here. Okay, so you don't need to be nitty gritty with your working. Okay, if you can see the result, okay, when you do extension papers, all right, they're taking that you have an assumed knowledge of the mathematics concepts. Okay, so you don't need to go simplifying, cancelling. You don't need to show that. Okay, if you're confident, you can write that answer straight down. Okay. Also, on thinking of it, your extension 1 exam will also include harder mathematics style questions. Okay, so it can be covered concept in mathematics, but more difficult style questions. So more towards the end of your exercises, okay, that would suggest to be more difficult mathematics style questions. Okay, right. So I've got x value. Then you need the y value, because you need the intersection of the 2 tangents. Okay, it doesn't matter which one you substitute it in, you will get the same answer. Okay, and that looks like a familiar result, doesn't it? Okay, so you might remember parts of your results, okay, but I wouldn't expect you to remember all your formulas, okay? Your best bet is to go and derive everything. But any questions so far? So this would be more like a difficult mathematics style question using extension 1 principles. Okay. Triple I. Prove that MT is parallel to the y-axis. Okay. So at this point I am joining the interval MT. In my diagram it's almost vertical. Okay. So now I need to justify that it is parallel to the y-axis. Add the information as you go. That's why we do big diagram, so that we can add it as we go, and we can look at the information in our diagram, then trying to go back to a question. Okay? So, to show that MT is parallel to the y-axis, what do I need to do? You don't know it's a vocal cord, so we can't use that yet.
Show the angles are equal or something like that.
Nope.
No.
What can you tell me about the coordinates of M and T for it to be parallel to the y-axis? X values are going to be equal. Okay, so we get the same x values, that means one's on top of the other, and it's going to be parallel to the y-axis there. Okay, so I need to show what. How do I show that the x values are going to be equal?
Find the coordinates of M.
Yep, what's M? Midpoint. So you need to use your midpoint formula to find the coordinates of x, the x value of M. Now, in your reading time, you're reading through the whole question, and before you start answering the question, you're again reading through the whole question, because the next question says, find the coordinates of the midpoint R of MT. Okay? So in order for me to find that coordinate, I need to have the coordinates of M. Okay? So you're not just stopping at your x values when you're finding the coordinates for M, because you will eventually need the y value. I will do that now. okay, rather than trying to backtrack and get that done, okay? So, m is going to be the sum of the x value, 2ap plus 2aq all over 2, and ap squared plus aq squared on 2. Summing your x and y values and taking the average. Dividing by 2's, which is taking the average. Right, we cannot factorise the p squared plus q squared. Okay, we can only do that if there's a difference. Okay, so that would be the error I made. Right, I had actually continue to factorise that, and then I realised no, I can't. Right, so that's coordinates of m. Okay, and in your nice big diagram, you'll be able to put that coordinate on m. Okay, if your diagram's not big enough, your diagram needs to be bigger. Okay, that's what I'm saying. Diagrams need to be nice and big.
Who's that face?
Which one looked like? Oh, I'm sure you work on this one.
Is your money coming with me?
Okay, so how do I finish this question? Are the x coordinates the same?
Yeah.
So that's what we need to state. Okay, the x coordinate of m is that, the x coordinate of t is that, so they're on the vertical line. Okay, so mt is parallel to the y axis since x values of coordinate of m and t are equal. Okay, you need to state something along those lines. You cannot just stop at the end of the coordinate, or you cannot just stop mt is parallel to the y-axis. Okay, you need to state the reason why, because you're asked to prove. I reckon we've got enough time to get through the rest of this question, so we can at least finish the question and get some progress in what we're doing for this topic. These types of questions topic. Find the coordinates of the midpoint R of MT. So R, sum your x value. So that's why I've got the diagram. A outside of P plus Q plus A, P plus Q over 2. And A outside of P squared plus Q squared all over 2 plus APQ, and the whole thing there is over 2. Okay, so attempting it is to substitute PQ equals -1 here. You cannot do that until you know you have a focal chord. Okay? Alright, so A outside of P plus Q plus A outside of P plus Q divided by 2. Right, so this is like saying x plus x divided by 2, which is 2x divided by 2, which is A outside of P plus Q. Okay, so if you need to take extra steps to show that, you need to take extra steps to show that. I'm going to put this over a common denominator. That's 2 or 3 steps in one. Do we understand how that works?
Yeah.
Okay, so if you're confident, you can go straight there. Alright, so that's the coordinates of R. One more thing I can do. I'm going to factorise the A out. So we've got P squared plus Q squared plus 2PQ. That can be round brackets, so just square, all over 4. So I've factorised the A out in both those terms. Alright, can I do any more to that? Alright, let's move on to the next question then. So the final question, and this is the where you're leading up, but you need to do all those things first, is D, find the equation of the locus of R. Okay, so the locus R is going to move depending on where P and Q is going to move. Okay, and also depends from the result where T is going to move and, of course, where M is going to move. Okay, so these 4 letters are moving in respect to each other. We need to find the path that R is going to take. Okay, to solve a locus problem, you need to get rid of the parameters. Okay, to solve an locus problem, you need to eliminate the parameters. So, from here, this is the midpoint of R. So we're going to use that information. We've got information already about R. So the x value of R is A outside of P plus Q, and the y value of R is that expression there. Okay? So at R, x equals A outside of P plus Q, and y is A on 4, P squared plus Q squared, plus 2PQ. We need to eliminate the parameters P and Q.
Would that be P plus Q squared?
Yes. Good. This is the expansion of P plus Q or squared, isn't it? A over 4 P plus Q or squared. Good. Okay, so if you get to this point here, I'm not going to mark you down, and I don't think HSC markers will mark you down because you're just finding the midpoint. However, you need to be able to do that skill, recognising that you can factorise that in order to help me solve the rest of the problem. So, what can I do from this point here? I need to eliminate the parameters P and Q. P plus Q is equal to x over A, isn't it? I've got P plus Q on this side as well. Right, so if I substitute x over A, where I've got P plus Q on the other side, I will then eliminate that parameter. Okay? Have we labelled any equations so far? We did 1 and 2 for the intersection of the tangent, so this must be number 3. And this is 4. So number 3 into number 4. Y is going to be A on 4 outside of x over A or squared. Now I've got rid of the parameter, I now tidy this up. Okay, the value of A is not a parameter, it is a constant length of the focal length. Okay, so A is not the parameter, it is a constant. P and Q are the parameters because these will move around on the diagram and it'll depend where it is for the value of P and Q. So A x squared on 4a squared. Y equals x squared on 4a. That looks familiar, doesn't it? So what can you tell me about the locus of R?
That's a parabola.
It's the original parabola.
Whoa.
Okay?
Whoa.
So, while it's not accurate on your diagram, it'll follow the path here. That is always the midpoint of the intersection of the tangent and the chord, and the midpoint of the chord. It'll follow the path of the parabola, whatever the value of A is. And that's the whole concept of this topic, okay? Doing questions like this. Right, so tomorrow morning, we're good for tomorrow. We'll finish off the last 2 questions, then we'll finish off this section. We have Introduction to Calculus extension to do, and extension functions and graphs. Okay, so a little bit to do. You can help by getting here as best you can on time, please. Alright. Otherwise, we'll be taking up about an hour of your time. Okay, make sure we get through this, ready for your exams. Do you find this interesting though?
Yeah.
I don't understand it, so.
Okay, it'll become clearer as we get these ideas in your head, and we'll talk about it again tomorrow. Okay, and when you start doing questions yourself.